water scarcity is going to be a problem for the Western United States for the next 100 years, and having improved observations of water in all its phases in the Western United States is going to be an important measurement as we see how our climate changes.
GPS was a crazy idea that they thought could be used to measure plate tectonics, and that's what I spent about my first decade working on. Then about 10 years ago, I started looking at earthquakes, so we could actually see seismic waves with GPS. And in doing so, I noticed that most of my data was corrupted by ground reflections. It was really irritating. We'd like it if all the signal went right to your antenna and my antenna, but in fact some of it's going to hit the ground and bounce off the ground and arrive at the antenna late. Well, this is bad. You don't want to be modeling something that's a straight line when it's actually something that's bounced off the earth and come back up to your antenna. And this is not a new thing. This is present in all kinds of radio systems, called multipath, or because it's taking more than one path. And what we've been trying to do is characterize those bounces.
I think that the neatest part of this is that we're using a signal that for a long time people hadn't really considered using at all. They thought it was just a nuisance parameter or maybe just an engineering number. We have a GPS antenna right there, and over here we have some of the other instruments that we are using. We have a rain gauge, we have a MET sensor that measures pressure, temperature, humidity, and winds. And then we have our solar panel that's powering the system. And then in our box we have a GPS receiver that's doing all of the data collection for the GPS part of it.
There's three things we're looking at. One is how does vegetation affect the bounces? The second is how does snow affect the bounces? And the third thing is how does the water in the soil affect the bounces? All three of those things can affect the bounces and do affect the bounces, and we're trying to quantify that so that climate modelers and atmospheric scientists can use that data, and farmers as well.
Hey, my name's Bob Munson. I'm now a farmer, and we're interested in soil moisture and crop development, and this device sees the whole field. And if you were a farmer, would want to know the soil moisture over the entire field, not just over a point where the little sources are at.
For soil moisture, vegetation, and snow. The combination, we can study plate tectonics at the same time we're trying to understand the environment.